let's start with the 7th question of exercise 21A. So in this question, see, it's cosecant to the power 4 minus cosecant square A, it's equals to cot to the power 4A plus cot square A. So this thing we have to prove. So we'll start with left hand side. And again, those things only we have to see. First of all, can we change it to anything? And if we can, then to which we have to change. So we can see this left hand side, it is in the form of cosecant, and right hand side, it's in the form of cot. So that means we have to change it to cot. So first thing, this thing we have to see. Then secondly, we have to see what is the relation between them. So that relation also we can write. See, all these things, if you keep on writing from the starting itself, it will be easy to prove this type of questions. So relation between cot and cosecant, it is with their square relations only, and I have told you in the previous video, 1 plus cosecant square theta, it is equals to cot square theta. Cosecant square theta. 1 plus cot square theta, it is equals to cosecant square theta. So relation also we know now that I have written. Then let's see now third thing which I explained you, that was algebraic expression. So can we use any algebraic expressions like a plus b whole square, a minus b whole square, a square minus b square? So out of those we have to see. So before that, this was 3 things I told you. Then fourth thing I'll tell you now. See, all these things in each and every question you have to see. It will be very easy to solve these questions then. Fourth thing, you have to see this thing. Is there anything common which you can take out? This is very important thing. In many of the question, by simply taking out the common thing only, you will be able to do it. So this is the fourth thing which you have to see. And now our question will start from this only. Why? Because see, left hand side it is cosecant to the power 4a minus cosecant square a. This I have already written. Now what is the meaning of cosecant to the power 4a? That in the previous question also we have did actually this thing. This is actually cosecant square a to the power 2 whole square minus cosecant square a. So this 4 we have just written as 2 and 2. 2 into 2. Because in the exponents you have already learned that powers, they can get multiplied if they are in this form. So 2 into 2 is 4. So I have just split it 4 into 2 into 2. So this way I have written. Now we can see this cosecant square a, it's present in both. So this is actually what? This is cosecant square a into cosecant square a. This is only meaning of square power. What is this? 2 to the power 2. 2 to the power 2 means 2 into 2. X square means what? X into x. Power 2 means multiplication of the number with itself. So that's what I have written. So cosecant square a, its whole square means cosecant square into cosecant square. Then cosecant square a. Only cosecant square a, just for better understanding of the next step, we will just write it as 1 into cosecant square a. Because if we multiply anything with 1, it means same thing only. 1 is the multiplicative identity of any expression, any number. If with 1 we multiply, the answer will be same. So I have just written cosecant square a as 1 into cosecant square a. Because 1 into cosecant square a is what? It is cosecant square a. Now let's take out common. This thing we are using. This thing you can see, cosecant square a is present in both. Whenever it is present in both, or anything is present in both the expressions, we can take out common. So I will take it out as common. Cosecant square a, I will write it outside. And now let's write the things which we are left with. So here this I have written out, this I will write inside. Cosecant square A minus sign as it is. And common only we can take if the expressions they are separated by plus or minus. See, this is one expression, this is one expression, it is separated by minus. So that is why we are taking common. Cosecant square A I have written minus sign as it is. Here cosecant we have taken out. See, that means we are only left with 1. See, that was by logic actually. Because if I would have written only cosecant, then here you people might like get confused of what to write, because nothing would have been there. So that is why I just wrote it as 1 into. So that if nothing is there, that means 1 is there. So this thing I have written now. Cosecant square A into cosecant square A minus 1. Now we have to keep on looking at the other side also. So other side, this thing we have to see. Cosecant cot to the power 4A plus cot square A. Now this thing cosecant square A. Here I have written also. Relation comes into picture. What is the relation? Because now our question, it's started from taking out common thing, then common I have taken, the next thing I have to change. Changing which I need. So I need quad. Now then for changing I need to look at the relation. Relation is this. 1 plus cot square theta, it is equals to cosecant square theta. So wherever now we are saying cosecant, let's change it to cot. So cosecant square, it's equals to 1 plus cot. So in place of this I will write cot square A. Don't write theta here. Same angle we should write. So this I have written inside bracket only. Again in place of this. Directly also you can write, if 1 you shift to other side, it will become cosecant square theta minus 1 is equals to cot square theta. 1 if we shift to other side, or if you don't want to do that, this cosecant square's value I will write again 1 plus cot square theta minus 1 as it is we will write. Plus 1 and minus 1 they will get cancelled, and same thing we are left with cot square theta. See, both ways, whichever way you feel comfortable you can write. So 1 plus cot square theta, somewhere see we have reached it, we have actually got cot square, and cot we have got which we need. Here cot square theta. Now one bracket is there, one simple expression is there, so this means we can multiply because we need something like this. So let's multiply. So this is actually bracket multiplication. So whenever any expression or term is outside the bracket, we have to multiply with both the terms inside the bracket, or all the terms inside the bracket. So cot square into 1, so that will become cot square theta, plus sign as it is cot square theta into cot square theta, that will become cot to the power 4 theta. Why 4? Because we have learned in exponents in smaller classes that when bases are same, powers will get added. So 2 to the power 4. So here also bases were same, cot square, or cot. Powers were like 2, 2. So cot and cot bases are same and they are getting multiplied. So we have to add the powers. So this I can also rearrange cot to the power 4 theta plus cot square theta. Because addition is commutative, we can interchange. 1 plus 2 is also 3 and 2 plus 1 is also 3. So we can interchange and then we can see I have got the required thing. So here all these things in each and every question you have to remember, and these only we will be using. 1 or 2 extra things also I will be telling you, but your questions they will revolve around these 4 to 5 things. Now let's do 8th one. 8th one also, if you want you can pause the video and try to do it. Then you can check out or you can see whether you have done it correctly or not. There may be more than one way to do or to prove it, but it depends how your mind works. Now 8th one, it says secant A into 1 minus sin A into secant A plus tan A. we have to prove this thing equals to 1. And 1, anytime when we are proving 1, most of the time when do we get? When I have numerator and denominator equal, and I just divide it, and on dividing same numerator and denominator, I will get 1. So this is one case. Other than that, we have many relations in which 1 is the answer. So this thing sine plus cos is equals to 1. Cosecant theta minus cot theta, cot square theta is equals to 1. Same with 3 relations we have. So these are the possibilities. Either we need square relations, or what we can do, we can make denominator and numerator same, so that on their division we will get 1 as the answer. Mostly this thing will be more helpful. In many questions you can see in this exercise that right hand side is equals to 1. So we'll use this concept only. Numerator will prove equals to denominator, or we will make them same. So left hand side, I'll write secant A 1 minus sin A into secant A plus tan A. Now we don't know from where I should start. So actually 4 things I have already told you. One thing is to change, other thing is to look out for the relations. Then I have told you algebraic expressions, then taking out common. These are the 4 things I have already told you. So out of these 4 threes, see, if you write these things before itself, you will at least have an idea from where I can start. Now we will start any question. If nothing, we are not getting any idea from where we should start, what we can do, we will start from change. We'll start from change, and change also, we will change everything in sine and cos form. So very important thing, if we are not getting any idea, like from where to start the question, how we can prove, so we will start from change. And change also, we will change everything to sine and cos form, because in reciprocal relations we have learned that each of the trigonometric ratio, it is somehow related with sine and cos. So that's what we will use here. So this thing, so let's change. Now secant's reciprocal relation, because I told you we have to change it to either sine or cos, and maybe to both. Secant A, secant's reciprocal relation is with cos. So SC, I told you, way to remember, secant with cos, cos with secant, and sine with cosecant, S and C. So secant A, its reciprocal is cos. So secant A, it is equals to cos A also, as per this thing which I told you. Changing into sine and cos, we can change it. Secant, I can write it as 1 by cos. Sine, no need to change because it's already in sine form. So I can write it as 1 minus sine A. Again, secant plus tan. So let's change it to sine and cos, or however like they are related. So secant, I have already written 1 by cos, I will write it plus tans. Tan's relation with sine and cos. Tan is sine by cos. So tan A, I can write it as sine A by cos A. Sine A by cos A. Now let's write it in more simplified form, because like 1 by 1. So 1 we need, other side 1 we need. So where I am focusing to make numerator and denominator same. So I just write it as 1 by cos into 1 minus sine A. This also I can just write as 1 plus sine A by cos. This we can write when I say I have to write 1 by 2 plus 3 by 2. So we can write it as 1 plus 3 by 2. So same thing, instead of writing denominators separately or I can say LCM, because it's addition of two fractions where denominator is same, so that means it's actually our LCM only. So we can write it as one single time. So I just wrote it this thing into this form I wrote. So 1 plus sine by cos A. Now this you can just consider as all these things as numerator, and each of these expressions also you can see they are getting actually multiplied, like 1 with this and this with that expression, they are getting multiplied. And here in denominator also, if we see, they are actually getting multiplied only, because from here to there, if you see, no sign is there. And whenever in algebraic expressions or in trigonometric ratios, you see that there is no sign at all. Like four mathematical operations are there: plus, minus, multiplication and division. Whenever there is no sign, so that means they are getting multiplied only. So that is why both of these are also getting multiplied. Now this thing we will see. This thing, if possible, it is 1 into anything, if we multiply it will be same. So here we can just see we have done one algebraic expression, a square minus b square. In previous questions we have used this one, a square minus b square. Its expansion is a plus b into a minus b. So here you can see a minus b into a plus b, where a is 1 and b is sine. So I can write it as a square minus 1 square is 1. So we can write it as 1, because 1 into 1 is 1. So 1 minus sine square a. A is 1, b is sine here. So a minus b into a plus b, it is a square minus b square. So a square means 1 square minus b square means sine square b, sine square a. So that's what I have written. Now cos a into cos a. This thing also we have done, cos a into cos a. It will become cos square a. Because when bases are same and they are getting multiplied, powers we have to add. In exponents we have already learned, so same concept we will apply here also. So here 1 power, there 1 power, 1 plus 1 power will become 2. 1 minus sine square a. Now this thing, relations. Their relations we have to see, and one thing, relations with cos and sine we have to see, because we are only left with sine and cos, and I am sure many of you come to know also what is the relation. So it is, we have done this thing, cos square a plus sine square a, it is equals to 1. Now we have 1 minus sine square a. That means sine square a we have to shift to other side. So this will become cos square a 1 minus sine square a. So which is telling us that 1 minus sine square a, it is equals to cos square a, again by cos square a. So cos square a by cos square a. So see, we have reached there when our numerator is same with denominator. So that's what I told you at the starting itself. In order to get 1, we can do this thing. So it will get cancelled and we will get 1. This thing, because if we have 5 by 5, when we are dividing same numbers, quotient we will get 1. So same thing, dividing, this is a symbol of division. So two same numbers or two same expressions we are dividing, so answer or quotient will always be 1, which is equals to right hand side, hence proved.